Hey guys, this is Mr. H. Hey, I want to do a quick video on how to simplify radicals. This is a skill that the Algebra 1 Regents exam is now requiring. You can't leave radicals unsimplified in your answer. They want you to simplify it. So they're expecting you to be able to reduce it when it's possible. And if it's not possible, then you leave it alone. But I'm going to go through this and I'm going to use a feature of the TI-NSPIRE that I think will help. So let me just jump in and get going. So the first example we have is it's the square root of 75. Now, a lot of teachers will tell you to use a factor tree and factor it down. So 75 can be broken into 25 times 3, and 25 can be broken down to 5 times 5. So here is the factored, prime factored form of 75. And now that you've got this, any pair of numbers that you have, you can actually pull out. So this will be 5. And then since there's only one 3, you have to leave it inside the radical. So the simplified version would be 5 square root of 3. Now, so that's what you should be able to do. You should be able to use a factor tree. But if you struggle with factor trees, or if it seems like too much, there is a feature on the calculator that will give you the prime factorization, and then you just have to be able to use that. So let me erase this and let's go. Let's do the square root of 80. And we need to simplify that radical. So what I'm going to do is, let me grab the calculator. So here I am just going to, there's a button, I call this the LeBron button because it's actually mini 23. And it's going to give you a factor button. And then all you have to do is put whatever number you want factored, prime factorization of, you put it inside and you'll see it's 2 to the 4th times 5. So if I go back to my sheet here, I can say 80 is the same thing as 2 to the 4th times 5. And I'm going to write this out because I like you guys to see this. This will be 2 times 2 times 2 times 2 times 5. So there's 4 2's that are being multiplied times 5. Now, what we're doing is we're looking for pairs. So every pair that you see, you can pull outside of the radical. So this is going to be one pair, and then this is the second pair. So this is going to be 2 times the square root of 5. There's only one 5, so it has to stay inside the radical. So my final answer will be 4 times the square root of 5. That's the simplified version. You can't do anything else with it. All right, let's do the square root of 8. Hopefully you know that 8 is the same thing as 2 to the 3rd power. So it would be 2 times 2 times 2. And of course, we're looking for a pair. So here's one pair. So we can take that outside the radical. And then the other 2 has to stay inside. So this will be 2 times the square root of 2. That's the simplified form. Now, every pair of numbers, when you bring it out, you only count it once. You don't say, oh, this is 4 times the square root of 2. No, this pair, this 2 pair counts as like one number. So that's how you would do it. So this is not right. All right, now I'm going to jump around a little bit because there's one I want you guys to really understand. Now, we're not going to have to do cube roots, but I decided that cube roots and square roots, if you understand the simplification process, it's a pretty simple process. So now I'm going to do I'm going to do the prime factorization of 64. So if I go here, I'm going to do menu 23, and then I'm going to put 64 inside, and it's going to tell me 2 to the 6th power, right? So that means if I go back, this is going to be 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2, right? Now, depending on what this number is, let's say it's a square root, that means we're going to be looking for 2 pairs. So here's one 2 pair. Here's another 2 pair. That's the second one. Here's the third 2 pair, right? So it would be 2 times 2 times 2, which would be 8. So the square root of 64 would be 8. Now, I'm going to back up. What if it was the cube root of 64, right? What if instead of square root, this was a 3? So it's the same thing. I lost a 2. It's the same thing. We're still going to be 2 to the 6th power, but now instead of looking for 2 pair, we're looking for 3 pair. And we have, here's 1 3 pair. Here's the second 3 pair. So then that means that we have 2 times 2 outside. So the cube root of 64 would be 4. Okay, because we pulled out a 2 here and a 2 here. So 2 times 2 is 4, and that's what you get. Now, I'm going to ask you this question. What's the sixth root of 64? Well, if you understand this process, you would say it's still 2 times 2 times 2 times 2 times 2 times 2. So now, instead of looking for a 2 pair or 3 pair, we're looking for 6 pairs of 2s. And we do have 6 pairs of 2s. So the 6th root of 64 is equal to 2, because we can pull one group of 6 2s out. That's how you do it. Now, let me do one more here. Is there a better? Yeah, let's do 108. First thing I'm going to do is I'm going to find the prime factorization. So I'm going to go menu LeBron 23. Or if Jordan's your favorite player, do Jordan. Menu Jordan. Oops, I put in 3. I wanted to put in 8. And I do this. And it says 2 to the 3rd or 2 to the 2nd. Times 3 to the 3rd. Let me move this up a little bit, and then I'm going to show you what we're doing here. All right, so I'm going to go over to the iPad. And so now I'm going to rewrite this as 2 times 2 times 3 times 3 times 3. Now, we're looking for pairs of 2s or 2 pairs of numbers. So here's 1 pair that we're pulling out. So that's going to be 1 2 outside. And then we have another pair of 3s that we're going to pull out, and that's going to be times 3. And then we're going to be left with this 3 inside because there's not another pair. So what our answer would be, 2 times 3 is 6, and we're left with 3 inside. So if you are looking for reducing square roots, you're always looking for pairs of numbers, and every pair that you can find, you pull outside. And whatever you pull outside, you multiply those, and whatever's left stays inside the radical symbol. All right, I hope this has been helpful. This is one of the things now when you are using the quadratic formula, or if you're completing the square, and if they ask you to simplify the radicals, this is what they're expecting you to be able to do. Hope this has been helpful. I'm going to sign off and post it.